everyone, and now we're going to look at rates of reaction. So, a rate of reaction, what do you think that means, Miss McLaren?
Well, I think the rate of a reaction is how quickly the reaction occurs, so you just measure the time. Easy.
Very good. So you have to, the time is definitely involved, but what are you going to measure during that time?
Well, I think you might have to answer that, Dr. Bourne. I'm a bit confused.
Okay, so let's look at a typical reaction. We have a typical reaction here. We've got the reactants, as you know, and we've got the products. Now, our first definition was amount of reactant used up. So look at the two reactants. What do you think about measuring those, Miss McLaren?
Right, well, if you have magnesium with hydrochloric acid, and it gives you magnesium chloride and hydrogen, so I would say that's the reactant as well as that, but I think that's going to be easier to measure. So if I say the amount of magnesium used up over the time taken, is that it?
You would be absolutely right, but put in the state symbols for this reaction.
I think I may be able to manage that. So we have magnesium solid, hydrochloric acid is aqueous, magnesium chloride is aqueous, and we have hydrogen, which we all know is a gas.
Absolutely right. Well done. Now, if we look at our two definitions, it's either amount of reactant used up per time taken or amount of product made per time taken.
Dr. Bourne, I'm just a little bit confused here. I understand it's the amount over time taken, but why do you say reactant used up and then suddenly you say product made?
Because if you think about the reaction, the reactants are being changed into the products. So as the products are building up, the reactants are going down.
Now you've made sense.
Yeah.
So now I understand the actual
definitions.
Formulas here.
Okay, so if you look at this now, do you think there's something else there that would be easier to measure than the loss in mass of magnesium?
Well, that equation reveals the answer, Dr. Bourne. I would say the easiest thing to measure would be the volume of hydrogen. Is that correct?
Excellent. That is absolutely right, Miss McLaren. It would be easier. And how would you measure that volume, do you think? What would you
Well,
use?
you could use, let's say, a gas syringe. It would
gas-
have to be
excellent, very good
graduated
answer, yes.
because it's important to measure the volume. So you're not going to measure in a test tube or a beaker.
No.
It has to have a volume scale.
Per unit time.
Per unit
So what
time.
else will you need?
We also need a stopwatch.
A stopwatch.
And we could measure per second or per minute. So
What's that going to affect?
it's going to actually affect possibly the units.
The units, very good. So if we were measuring a gas per for the volume, what would the units be?
Well, if I measured the volume in cm cubed, so for experiment 1, it would be cm cubed. And if I measured the volume per second,
Yes.
then it would be cm cubed per second.
Excellent. Very
Thank
good.
you, I'm
And
getting it right
Is there
now.
another way of writing that?
Yes, you can write it as, if I just rub that out here, it's cm cubed per second, which is known as cm cubed s to the minus 1.
Lovely, and that's the same thing. Fantastic. So that's the first example we've looked at here for this reaction, this definition. Now look at this definition, amount of product made. We did that here with hydrogen, but look at this rather more complicated reaction. That was the one we might know, but this one is one we might not know. So the first thing, Miss McLaren, is put in the state symbol. See if that gives you a clue.
Right, now, hydrochloric acid is aqueous. Now, this is known as sodium thiosulfate solution. You'll always be getting the formula, so don't worry about having to remember this. And I know that's in solution. Sulfur dioxide, we know is a gas, and it's not particularly nice smell. I love lovely smells. And here we are. Gas, sulfur, I know is solid. It's a yellow solid. And we have sodium chloride
Now,
solution.
can I just stop you there, Miss McLaren? Because you've written gas.
Oh my
So
God,
It
did I
was
say
a
gas?
deliberate mistake to see if I was still awake. Right, off we go.
Solid, and then we have aqueous, and then we have water is liquid. Dr. Bourne, could you check my state symbols, please?
I think I'll have to, but you're absolutely right. So now we've got aqueous, so two solutions, a gas, a solid, a solution, and a liquid. And you've got to think which would be the best one to measure for amount of product made per unit time.
Well, we could measure the gas
Possibility,
produced per unit
possibility.
time. Sulfur dioxide is quite soluble.
Yeah.
So I'm going to go for the office one, which I got the state symbol wrong. That was a deliberate mistake. I'm going to go for the sulfur solid.
Absolutely right. So you'd measure the solid per unit time.
Yes.
Have you any ideas how you might do that?
Well, solid, you would have to measure mass, so it would be in grams. And I would use the same time per second or per minute
So the
at the moment.
units would be
The units for experiment 2 would be grams per second, or, as you mentioned about the other way of writing this, it's grams per second.
I think that's fantastic, Miss McLaren. I think so. You look at which of the reactants or products would be the easiest to measure over the course of the reaction, and you time it, and then it's just mass or volume, whichever you've done, per unit time.
That's right. I didn't realise rates was so easy.
I think our time's up, Miss McLaren.
So do I, sadly.
Bye.